Hi all, good evening. Today we'll look on the concept of binomial random variable and binomial distribution. So what is a binomial random variable? Let x be a discrete random variable and let n be the number of trials and p be the probability of success. X follows binomial distribution, that is x is following binomial distribution with two parameters n and p. Okay, you can see here number of trials is n and p is the probability of success. And the probability mass function is given by probability of x equal to ncx p power x q power n minus x, where x runs from 0, 1, 2, 3, etc. n, and p plus q equal to 1, where q equal to 1 minus p is a failure. So this is the probability mass function of binomial distribution. Now let us find the moment generating function of binomial distribution, and hence we can find its mean variance from the moment generating function. So the MGF of x is given by mx of t equal to expectation of e power tx. This is the formula. And we know the expectation of e power tx formula is summation e power tx into probability of x equal to x. So this is nothing but the probability mass function of binomial distribution. Now, based on this probability mass function, the x variation is from 0 to n. Okay, so x runs from 0 to n. So when you substitute p of x equal to x, I mean the probability mass function, you can see here ncx p power x q power n minus x, and x runs from 0 to n, and your e power tx is as such it is here. Now you can write this e power tx as e power t whole power x. Okay. Now this e power t whole power x and p power x can be combined together, which can be written as p into e power t whole power x, and you will be left out with ncx q power n minus x. Right. Now you just substitute the value of x to be 0, then 1, 2, 3, it goes on till n, okay, because it is a finite expansion. So substitute 0 in these places, you will get this first p power t whole power 0, nc 0, q power n minus 0 plus p power t power n nc1 q power n minus 1 plus p power t power 2 nc2 q power n minus 2 plus etc. p e power t power n ncn q power n minus n. Now these terms are 1 because we know nc0 is 1. I'll write here, you can see nc0 is 1, ncn is also 1. Okay, and anything power 0 is going to be equal to 1. So based on this criteria, you can see here these conditions, you'll get only q power n here, and these places you get all the other terms, okay, as such like the previous terms, but at the last term again ncn is 1 and q power 0 is 1, so you'll be getting only this term, okay, here. All right. Now this looks like x power n plus a nc1 x power n minus 1 plus a square nc2 x power n minus 2 plus etc plus a power n, which is nothing but the binomial expansion of x plus a power n. You can see here your x is nothing but q and your a is nothing but p e power t. So when you club it together, you will be getting q plus p e power t whole power n, which is nothing but the moment generating function of binomial distribution. Okay. Now from equation number 1, that is a moment generating function, you differentiate this mx of t with respect to t one time, and you substitute t value as 0, you will be getting the mean. So that is what we are going to do in the next step. So differentiate 1 with respect to t on both sides. So when you differentiate this side, this is nothing but your mx dash of t, and the other side will have n into q plus p power t power n minus 1 into q plus p power t differentiation is q differentiation is going to be 0 plus p power t differentiation is p power t, which is what written in this step. Now you can closely watch these terms. Now in this term, when you apply t value as 0, so wherever t is there, you put 0. What will happen? You can see here n into q plus p 0 power n minus 1 into p e power 0. Since e power 0 is 1, you'll get 1 here and here 1. So you'll be having n into p, q plus p power n minus 1 into p. And we know very well that p plus q is going to be 1. Substitute here, and 1 power n minus 1 is 1. So you'll get only n into p, which is nothing but your expectation of x, and that is your mean. So e of x is n into p, which is the mean of binomial distribution. Now, when you want to get the variance of x, what should we do? You have your mx of t here, and you have differentiated your mx of t, which is mx dash of t. Now, again, you differentiate this one more time with respect to t. That means you are differentiating mx dash of t again with respect to t, which will give you the second derivative of mx of t with respect to t. So, this is the first derivative. So, when you do one time differentiation again for mx dash of t, that will be giving you d by dt of mx dash of t, which is mx double dash of t, and you are supposed to find this by taking this equation number 2 and differentiating this quantity with respect to t. But then how will you differentiate? You have here n, you have your p, these are constants, so take it outside. You only have this quantity and e power t multiplied together. So I just took everything and I'm going to use only this quantities, that is q plus p power t into power n minus 1 into e power t. So what I will do, I'll assume this as some u and this as some v, and I will use u v method. So keep this term and differentiate e power t, which is e power t only, plus keep e power t and differentiate this term. That's what we have done here. Q plus p power t power n minus 1 into e power t differentiation is e power t, plus e power t into q plus p power t power n minus 1 differentiation is n minus 1 q plus p power t power n minus 2 into q plus p power t differentiation is p power t, because it is a function of function rule, right? Now you're supposed to substitute t value as 0, and that will give you e of x square. So wherever t is there, you can see here this place, this place, this place. Okay, all these places you have t, which I marked in red. All those places we have just made it as 0. You have to write 0 here, and you'll be writing it here. Okay, so once you do that, it will get simplified because e power 0 is 1 as we know. Okay, give me a minute. Yeah, e power 0 is 1 as we know, and we also have these terms like q plus p power n minus 1 and n minus 1 q plus p power n minus 2 into p. And you know very well p plus q or q plus p is going to be 1. So these are all 1. And you will be left out with 1 power n minus 1, which is again 1. This side again it's 1. So n minus 1 into p. So that will give you 1 plus n minus 1 into p. And when you multiply n into p inside, you get np minus p. So you get np, there is an np which is outside, please remember that. Np into 1 plus np minus p. Multiply np inside, you will get np plus n square p square minus np square. So this is your mean square value or expectation of x square, which is used for finding the variance of x, right? Now let us find the variance of x, e of x square minus e of x whole square. We know very well e of x square, which has been computed before, that is np plus n square p square minus np square minus minus e of x whole square, that is np square. So when you do that, what happens here is np whole square is nothing but n square p square. Now this n square p square n square p square gets cancelled, leaving out np minus np square. Now take np common, that will give you 1 minus p. But what is 1 minus p? Since we know that p plus q is 1, q is 1 minus p. So it will be npq. So the variance of binomial distribution is npq. Now I just boxed it. The mean of binomial distribution is np, and the variance of binomial distribution is npq. And when you want to find a relationship between mean and variance of binomial distribution, you just divide mean by variance. That will give you np by npq, which is going to be 1 by q or 1 over q. Now we know very well that q is less than 1. Okay, that gives 1 by q is greater than 1. So when this quantity is greater than 1, your mean by variance is going to be greater than 1. That's going to give a relation mean is greater than variance. So in a binomial distribution, mean is always greater than variance. So we'll look on to the problems in the next session. Thank you.